Okay, so to let us have a glimpse about how Earth observation can help in carbon cycle assessment. So we will go through some basic slides as well as some innovative slides on Earth observation for requirement for the carbon cycle assessment. A certain issue will discuss on status, challenges and issues also. So first of all, we all should know how this carbon means carbon dioxide. Carbon dioxide which has got atom 44 atomic weight. It has got carbon has got 6 proton and 6 neutron. And if we see, carbon is the main elemental part in every body of every life on the earth. So without carbon, nothing, there is no life on the earth. So it is the most abundant element on the universe, and it is the important particularly with respect to making food for the life on the earth. So what I want to say, carbon dioxide or carbon, that is the playing a most important part in the regulating chemistry part of the life on the earth. And apart from the chemistry, if we see from the physics side, carbon is an important element also that forms blanket around the earth, greenhouse blanket. So this blanket, what it forms, has the ability to trap heat of the sun. As a result, it can prevent earth from freezing. So if the carbon dioxide gases is not there in the atmosphere, and a net energy balance or radiation balance would have been different. We cannot maintain the balance, radiation balance. As a result, sometimes what will happen, polar region will become cooler and cooler, and your equator and all those becoming hotter and hotter. So there will be no life on the earth. So this is a carbon that is regulating the heat distribution, and finally it is making the radiation balance of the earth in the correct balance. So what in general way, carbon cycle, it is simply the constant exchange of carbon among different reservoir or biotic or abiotic world. Different reservoir means it may be a biosphere, means I mean land, it may be an ocean, it may be an atmosphere, it may be a hydrosphere. Hello? Hello? No, I haven't answered. No, don't. Constant exchange of carbon between biotic and abiotic world, thus forming cycle which is called carbon cycle. So it may be atmosphere, hydrosphere, biosphere, or you can say this soil, vegetation and soil. So carbon cycle also plays important role in maintaining atmospheric carbon dioxide level in the atmosphere, earth atmosphere. Because if this level is not maintained, then all of we know carbon dioxide is the most culprit gas that trap heat and revert back to the earth. So which is called greenhouse effect, because of which global mean temperature is increasing. So because of this carbon dioxide, if it goes on increasing, there would be a danger or threat to the rising of global mean temperature, which may cause no life, or maybe which may cause threat to the life on the earth. So if you say the status, concentration of these carbon dioxide gases, which has increased from almost 280 parts per million to 387 parts per million in almost 150 years. And still it is continued to increase at the rate of 1.5 ppm per year. But recently, beyond 2000, now it is increasing beyond 2 ppm per year. And it has reached almost to 415 ppm as of now. So we understand here carbon cycle. As I said, it is simply a flow of carbon among different reservoirs. It may be vegetation, soil, ocean, atmosphere, different reservoirs are there. Constant exchange of carbon between these different biotic as well as abiotic world, and this forms the carbon cycle. So if we start understanding from the sun, how this carbon cycle happens. One of the most significant component that drives the carbon cycle at the Earth's surface is the sun energy. Sun provides energy in the visible wavelength, or it is in the photosynthetic active light, which is useful in photosynthetic processes. By this photosynthesis, plant can make food. So almost 120 pentagram of carbon or carbon is being absorbed by the vegetation through photosynthetic process. What is photosynthetic process? It is simply a conversion of carbon dioxide in presence of water and light with the enzymatic activity like Rubisco enzyme. It convert into a carbohydrate C6H12O6 and some O2 release. So that is a photosynthetic process. During daytime, this photosynthesis occurs. Then there is in the particular process, there is a soil underground. So some part, all these residues, crop residues, or certain organic matter, or whether it is an animal death or whether it is a plant debris which is incorporated into the soil as an organic matter. That organic matter, decomposition of organic matter is driven by microbes. These are the microbes called heterotrophs. They are called heterotrophic bacteria. So heterotrophs which causes decomposition of this substrate. As a result, CO2, this whatever dead material, which is converted into a CO2, and that CO2 is released to the atmosphere. Similarly, whether animal breathe, then it releases carbon dioxide to the atmosphere. Whether animal is cattle, goat, or human being, all respire or breathe and release carbon dioxide to the atmosphere. At the same time, they are fed also the plant material and also animal death. When it converts into it is also result into a dead organic waste product like cow dung. All are organic waste product, and also even animal death, that is also converted into a dead product or organic matter. Further it decomposes and it may also lead to the respiration. So whether it is the microbial respiration by heterotrophics and dead material, all those respire and release carbon dioxide to the atmosphere as a soil respiration. Apart from that, there is also a roots. Roots also respire. Rhizobial respiration as well as root respiration. So root also respire. Then apart from root, there is leaves, stem and bole. Because like human being, we take oxygen and release CO2. Like this plant, they take CO2 and release O2, but at the same time, they respire also during night time. This plant respiration that take place during the Okay, this plant respiration, it takes during the daytime, not sorry, night time, daytime also and night time also. So plants, stem, bole, leaves all have ability to respire. Why we respire? Why this plant respire? Because like what? We respire also for maintenance. Suppose you have taken a heavy food, oily food, and if there is a hot weather, what will happen to your breathing? You will respire, or your breathing rate will be very high because you respire more maintenance of biomass, because if you are heavy food, your metabolic energy, metabolism is faster. As a result, more respiration will be there. Similarly, in case of plant also, if more biomass is there, for maintenance of this plant biomass, plant can respire. Then there is also industrialization. Because of industrialization, there is a burning of fossil fuel. Because of burning of fossil fuel, that is the main source of carbon dioxide released to the atmosphere. That is the industrial emission. That is the main source of carbon dioxide released to the atmosphere. The factory and this all emission. And some part of this, okay, all dead organic matter, that okay, sedimented in the transfer through rivers, and it is sedimented in sedimentation process will be taken place in the river and the lakes. So it will go to the ocean, and there is a silicate or some weathering. Sedimentation will take place in the ocean. So that particular ocean is the major sink of the carbon. Highest amount of carbon is being stored in the ocean, followed by soil, then atmosphere, then vegetation. That we'll see in the next slide maybe. So why this carbon and terrestrial ecosystem, that understanding we require? Because as we know, we have talked or we have heard quite many times IPCC, Intergovernmental Panel on Climate Change. They are devising different kind of strategy to mitigate climate change. But what mitigation process is required? That depends on the successful alteration of the nature as well as managed system. So particularly IPCC has already admitted or identified terrestrial vegetation, means whether natural or managed vegetation is the one of the most important alternative or effective option available with the any countries for the carbon sequestration of the greenhouse gases. So terrestrial carbon sink is the one of best option that every government want to push through afforestation program or through some green technology, using okay some zero tillage or some grassland cultivation or biofuel crop. All those high biomass crops all can help to sequester carbon and reduce the amount of carbon present in the atmosphere. So currently, if we see the total carbon pool, so as I said, current terrestrial sink on a global level is around 500 to 700 pentagram of carbon you will find in the vegetation, and around 1200 to 1600 carbon in the soil. In the atmosphere, it is around 750 pentagram carbon, and ocean it is more than 35,000 pentagram carbon. So here you can say this particular vegetation, which has got great potential to offset total amount of carbon which is emitted and accumulated through the all possible sources. Because one way is that you can reduce carbon emission through industrialization, through okay putting the different kind of green technology, green energy like okay solar power generation, some other wind energy, or we can reduce some clean development mechanism. So through all those things, we can reduce to certain extent. But at the same time, development agenda, because development and economy, it has to go. So we shall see different options like terrestrial, improving terrestrial carbon sink. We cannot restrict the development. Industry, energy sector, and all those things is very much useful for the driving economy as well as the livelihood of the people in country like India. So we shall bring out a new option of reducing carbon from the atmosphere through more and more terrestrial carbon sequestration. So over the period of time, there are many international agreements and protocol. Like first in Paris Kyoto Protocol. Under this, a framework was designed for reducing emission of the greenhouse gases. As per this protocol, there was a joint commitment by the industrialized country, mainly the European countries, China, this US, which are the most emitter. Meaning they have almost more than 67 three countries. They emit even more than 10 times than India. So they are the industrialized country, have higher rate of emission of greenhouse gases. So there was a joint commitment in Kyoto Protocol that they can reduce as well as provide certain kind of financial obligation to help developing countries like India and others to have this green technology or to help in reducing emission of the greenhouse gases through carbon trading or other mechanism. So understanding this mechanism of carbon source and sink variability among terrestrial ecosystem is very much important, because all this, finally what we need to better understand how much carbon we can sequester in the land or in the terrestrial biosphere, so we can reduce the target, reduce the emission target for the country. So this understanding of CO2 source and sink variability among different terrestrial ecosystem, because there are different kind of vegetation type and different kind of system, agro ecosystem as well as forest and wasteland and also grassland ecosystem. All has got different kind of characteristic and having ability to sequester as well as release carbon. So it can help, and if we have knowledge, it can help to better design the strategy to spread or to encourage the kind of particular ecosystem carbon sequestration mechanism to have better understanding on the terrestrial biosphere and the atmospheric interaction. Now already we have discussed that carbon dioxide, it is one of the most culprit greenhouse gases. But if you see that it has got ability to contribute global mean temperature increase in the order of 1 degree to 2 degree in the current century. So why it is most culprit? Because of its abundance. It is not having the highest anthropogenic value, but because of its abundance in the Earth atmosphere. It is the fourth elemental element in the Earth atmosphere. After nitrogen, this oxygen and the argon. Increasing concern has also promoted local and this different organization and NGO and other community to further consider new option for increasing, mitigate the further increase in the carbon dioxide. But if you see, most of the approach, whether it is by NGO, some green NGO energy development or any organization involved in the developing clean area development mechanism or green energy development. Here, what we see is particularly the natural and the managed ecosystem. If we successfully manipulate or alter this natural forest or managed agricultural ecosystem, which has got major role to play in governing the active cycle of the carbon across our system. So we need to better understand how we can successfully manipulate this natural and agro ecosystem, forest and agro ecosystem, for improving carbon sequestration from the atmosphere. And because of this, knowledge of carbon cycle is essential for successful application and deliberation of carbon management strategy, as well as giving input to the national climate change program. But all those good things to go in the right direction, we need also quantification for policy, verification and support from the political leadership and advisory. Because if you policy this carbon sequestration, terrestrial carbon sequestration, as a sole alternative or option for reducing emission, greenhouse emission, has to be dealt at the policy level. So government, now our government is very much positive. As per the Paris Agreement, our government is pushing very correct in right direction, and also emphasizing how India can contribute to reduce the emission, greenhouse gas emission through carbon sequestration, and also emphasize that forest, we are going to have 2 to 3 billion tons carbon sequestration in a very near future through afforestation program. So this is all good commitment made by our government, mainly Ministry of Forest, Environment and Climate Change, with regard to mitigate climate change through carbon sequestration and reforestation program. So globally, this is if we see total carbon cycle, if we see globally, there is a atmospheric. So from atmosphere, it is around 120 petagram carbon. It is absorbed by the photosynthesis. Out of this, 60 pentagram goes out through respiration. In ocean also, 92 is absorbed and 90 goes back to the atmosphere. In 1990s, I am talking. But industrial fossil emission is also very much high. So I am searching one slide. Okay, where? Yes. Okay, no issue. So particularly if we see the fossil fuel, that is around 5.4 pentagram carbon. So if we reduce that 3.2 carbon sink by ocean and land, still it is a 6.4 from the fossil fuel, still it is a 3.2 pentagram carbon every year added in the atmosphere in 1990s. In 1990s, that 3.2 pentagram carbon is still added in the atmosphere in 1990s. But currently, now in 2012, this has gone to 4.7 pentagram carbon is added every year to the atmosphere. So there is a rising of the atmospheric CO2 because of this fossil fuel. Because carbon sink is also improving. Earlier in 1990s, it was 3.2 pentagram. Now, okay, majority of participant, pentagram is 10 raised to 15 gram carbon. So 3.2 pentagram carbon was seen by the land and ocean in 1990s. In 2010, this zinc has increased further to 4.3 pentagram carbon. Now today it is a 4.7 pentagram carbon. Zinc is there to the 4.7. So, but still carbon added to the atmosphere is also increasing because fossil fuel emission is also increasing. So here let us understand how this earth system feedback and atmospheric CO2 rising. So if you see the different sector like fossil fuel, here you see there are different kind of agencies are there. The NOAA, CMDL, now IRSL, International Organization and agency, which are monitoring carbon dioxide with the high density output in different network of the observation. There are 100 sites are there in marine location to monitor this carbon dioxide measurement. Long-term data is there. Seasonal cycle is also available. If we see this up to 2010, you see carbon dioxide concentration in the ppm, parts per million. This has increased drastically from 1960 to almost 400 in 2010. As of now, it has already reached to 415 or 20. 415 to 420 per ppm. So before this 1960, if you see last, there was a cyclic in nature. There was no much increase in the atmospheric concentration of the CO2. In the last, before this 1950 or before 1950, it was almost less than 300 for almost 1000 years. It was cycling in nature. But this steep rise in the atmospheric CO2, we could notice beyond 1960 only. Now, what are the reason? Reason is mainly the carbon sequence. This carbon sink has been increasing from 1980 onwards. So you see tropical land, extratropical, this is all carbon uptake. What you are seeing, that is a tropical land uptake, extratropical land and ocean. This is all carbon uptake. But fossil fuel, that plus sign, that means it is emission. So 9 minus 6, this it will give you around 4.7. Okay, there is a residual sink of 0.6 pentagram carbon is also there. But 4.7 pentagram carbon, that is our gigaton carbon, is added to the atmosphere and which is finally causing rising of the atmosphere. So whether even though we have very good terrestrial sink by vegetation, terrestrial biosphere, there is an ocean sink, even though there is a large amount of fossil fuel emission on a global level, which is causing further increase in the rising of the atmosphere. This is not the case that India is only contributing. It is India's contribution to the greenhouse gas emission is really 1/10. That what we can see here from this. You see this up to 2020, from 1960 to 2020. China, from 2000 onwards, it is fossil fuel emission of the CO2 is very high, almost 8 to 10 gigaton carbon. Then USA, since 1960, it is already developed country from 1960 itself. So it has got very high industrial development, and from 1960 itself, it is emitting more around 4 gigaton carbon. European region, they are also emitting around 2.6 gigaton carbon. But you look at India, we are up to even 2010, we are emitting almost negligible. But now our development, India is developing faster with the more industrial development and other network, energy sector as well, power and all those things. The large scale development is going on. Now we are slightly increasing with respect to the emission of the fossil fuel CO2. But even though it is less than USA, European and China. So we are the fourth country now as of now. But if you see per capita, because our population like US, it is hardly 35 to 40 crore. Our population is almost 35 crore. So per capita, if you see per capita fossil fuel emission, we are almost emitting 1/10 of the what done by China, USA and other countries. So that point of view, we are still in the good way of not emitting more, but at the same time we are sequestering more and more carbon through our enhanced terrestrial activity. You see, for India, like emission CO2 in the atmosphere, this is a long-term record of some CO2 measurement site in India. One is a Sigar, and then these two sites, CRI and SNG. This is in the western South India, peninsular India, and these two, yellow and red, they are the nearby global site. So you see, carbon dioxide has been increasing from 375 from 1992 onwards. From 375 ppm to as of now, it has reached to almost 420 to 425 parts per million with the CO2 monitoring site. Now let us understand how this global carbon cycle works. The global carbon cycle assessment is done globally. So there is one project called Global Carbon Project by East Anglia University. There is a Professor Per Kendall who is publishing as a part of chemical carbon cycle process recap. They are working out every year carbon budget on a global scale. So you see the status of carbon cycle from 2009 to 2018. How much fossil fuel emission? It is around 35 gigaton carbon that is released to the atmosphere through different industrialization. But you see land, then from land also there is a deforestation activity, land use change, all also responsible for releasing carbon. So you can see land also, it is releasing around 6 pentagram carbon. But biosphere, at the same time, apart from deforestation, afforestation, different well luxuriant vegetation, natural forest, which are not degrading, they are causing increasing sequestration of the carbon. So 12 pentagram carbon is, or gigaton carbon is added. Then atmospheric CO2 in 2009 to 2018, this is a whole month mean. 18 is added. 18 per year, particularly 18 atmospheric carbon, that is added to the atmosphere. Ocean 9 is absorbed. 9 gigaton carbon is absorbed. So here what I want to say, this plus, and this is okay, all this okay. 1, 12, 6, 18 plus 9. 18 plus 9, that is 27. 27 you minus okay from this okay 35, okay. Then this okay atmospheric added. So if you make this okay balance of this okay fossil fuel, atmospheric and this, still there is a budget imbalance is a 2 pentagram carbon. These are all positive. This is okay, all this okay going away. These are all these 2 35 plus 6 means 41. 41 minus this 27. Okay, that is something okay. You will find added to the CO2, and this is a carbon budget 2%. Okay, for 2009 to 2018 budget imbalance is a plus 2, means plus 2 gigaton carbon is added to the atmosphere in over the period of 2009 to 2018. Similarly, here you see the comparison of the global carbon budget for the 2020 and 2019. Here why I want to emphasize, because this year all of us have seen pandemic, COVID pandemic, and we all have seen there is news report and also some research studies also people have carried out. Because of this lockdown, there is a lockdown has got significant or substantial positive impact on the reducing carbon emission or greenhouse gas emission. So emission has reduced because of this lockdown put across the world. And this is a true story that in 2002 emission, fossil fuel emission, you see fossil fuel emission has reduced. Top box is this is a 34 gigaton carbon as compared to the 36.4 gigaton carbon in 2019. So that fossil fuel emission has reduced because of lockdown effect. And because of this terrestrial, this okay, this time okay, we have got budget imbalance is only 1, means only 1 gigaton carbon is added to the atmosphere in 2020 because of this reduction in the fossil fuel emission. At the same time, biosphere, okay, you see biosphere activity 2019, biosphere activity, that carbon added to the vegetation, it was very good in 2019, but 2020 again it is decline little bit amount of carbon sequestration, and then ocean is almost same, land use change it is almost same, but little bit that is because of lockdown and some abundant activities, farming activities as well as some vegetation activity for increased forest fire in subsequent years 2019 and further 2020. So some carbon sequestration by the biosphere has little bit reduced in 2020, but overall because of lockdown there is a positive impact on reducing carbon in the atmosphere. So why we are talking all those things? Because we need to understand how much this ocean and land contribute towards absorbing carbon from the atmosphere. That is the research focus, or that is the strategy being followed by every government to mitigate climate change program. We need to quantify regional carbon budget and also regional target of reducing carbon emission through terrestrial carbon sink. So we are focusing on enhancing carbon sink through afforestation or other greening activities, and finally reducing this deforestation, redo emphasizing more on redo, we finally get improvement on the terrestrial carbon sink. So here you can see this is a fossil fuel carbon that is emitted, the gray areas. But here, this particularly this land use change, which is a hardly okay deforestation program, means almost 18% contribution of total emission is there. Then ocean is the major sink, then this is the land sink. So land use change means deforestation and emission by the fossil fuel, industrialized emission. They are mainly the sources of carbon, and then ocean is a sink of the carbon. It is storing the carbon from the atmosphere. Land also storing the carbon from the atmosphere. Then finally, if you imbalance, that is a whatever imbalance between this and this, that will store in the atmosphere, this carbon, atmospheric carbon. Because if balance is not there between these two sink and the two source, then whatever left is the added to the atmosphere as a atmospheric carbon pool, and it will give rise to rising of the atmospheric CO2. So here you are seeing in the light gray area, that means over the period of from 1940 onwards, there is a rising of the atmospheric CO2 because of there is a carbon is every year added to the atmosphere because of imbalance between the source and sink. But apart from all those things, here you see there is a one from 90, 20, 40, also in some part, okay, even in 2000, there is a missing sink is there. There is some part, if even we take into account the atmospheric carbon pool as a sink, and we balance with the sources, fossil fuel and the land use change, there's even those there is some amount like 3 to 4.5 pentagram carbon as on today, that is a still remain as a missing sink. There is a residual sink is still there, and we need to understand now where these are the location of this missing sink, where how we can improve this, identify this sink and its location, so we can further improve the sink capacity of our terrestrial biosphere. So in India, on similar line of global carbon project, global carbon project or global international agency like International Geosphere Biosphere Program, for those they have very detailed carbon balance budgeting, and the agency many sectors and agencies are involved to generate carbon budget and understand carbon cycle. But we have also initiated in a modest way a national carbon project by our project director, Dr. V.K. Dadwal, who was our dean earlier, Indian Institute of Remote Sensing, and also director, National Remote Sensing Agency. So their national project, carbon project, we have decided different kind of goals to meet our information or generate information about national carbon budget, or also inform our national government to have communication related to United Nations framework on climate change. So national communication to the climate change program. This project was initiated to deliver certain input for the NPCC. So goal were assessment of carbon pools, fluxes and net carbon balance. And also apart from this, we have established network of observation site for carbon budgeting, and also use remote sensing based modeling and upscaling technique for assessing carbon cycle. Whole project was categorized into a 3 sub-project: vegetation carbon pool assessment, soil carbon pool assessment, soil vegetation atmospheric carbon flux. And this project has got major focus on use of remote sensing new remote sensing data, new observation and the algorithm, and development of national database. So finally, all observation, survey, field survey, ground survey, plot scale measurement on biomass or soil, carbon or fluxes are integrated to develop integrated modeling system for generating partial database of carbon cycle component. So there was a huge team involving various centers across India, not only Indian Space Research Organization, but university and other research organizations. So here, okay, we to see what kind of observation we should study or we should make to understand the carbon cycle. Measurement of, first of all, we should be aware about measurement of the CO2 and the methane in the atmosphere. That is the key observation we supposed to make. Either we can measure it through some ground network or we can do with some satellite observation. As on today, some satellites are also available, like okay, SciMachi or even GoSat or OPO2. By inversion of CO2, we can measure CO2 fluxes also. So measurement of CO2 and methane, that will help you. Methane here in the equivalent to the CO2. So both these can help us in identifying major sinks and sources. Sink means those systems which absorb carbon. So which are okay, sink, which are having a more absorption uptake of the carbon. And those systems which are releasing carbon to the atmosphere are the sources. But by having integration of measurement, either from network of in situ site, plus tower, or satellite observation, we first need to understand what is the magnitude of the sink and source, where this source and sink located, because we need to identify the missing sink. So we need to identify which are the location representing the sink of the carbon or source of the carbon, and also we need to quantify the duration of the carbon sink and source. If we do all these things, then we can correctly quantify the carbon budget of the region. Second, we need to also, apart from the fluxes that describe sink and source, we need to also measure the pools, like soil carbon pools or vegetation carbon pools, and also ocean. So, because ocean is the major sink of the carbon, so measurement of this carbon stock both in land and ocean, inland water, is equally important. How it can be done? It can be done through carbon sequestration, through biomass carbon storage. We shall have to quantify biomass carbon across the land as well as in the ocean through phytoplankton carbon sequestration, soil organic carbon, carbon deposition and sedimentation process in the ocean, by weathering carbon, soil erosion, how much carbon is transported and sedimented into the ocean or transported by rivers, all is a part of the carbon cycle. Fourth is the observation of key cyclic process in the land and the inland water. Because we need, apart from this sourcing, we need to have certain carbon cyclic process, like whether different component of carbon cycle, heterotrophic respiration, erosion, runoff, as well as photosynthesis, all we have to measure or observe for constraining different kind of ecosystem model. Because these are the observations. They cannot be representative of whole big landmass like India. But we should be very much cautious about modeling activity also, observation are very critical. So we need to observe these different carbon cyclic process and use them for constraining different ecosystem model, which can give you a large scale carbon budgeting exercise. So let us understand also certain terminology which I am using throughout this course. Carbon cycle, already we defined that it is a biogeochemical cycle that influence flow of carbon through and among carbon reservoir, including terrestrial biosphere, atmosphere and ocean. That is carbon cycle. But why we need to have monitor this carbon? That's carbon monitoring. The sustaining way of estimating all carbon dynamics, there are needed to estimate total carbon exchange between biosphere and the atmosphere. This is carbon accounting. This is a one form of carbon accounting. Sustaining way of carbon monitoring, how much carbon is being exchanged between the biosphere and atmosphere through net ecosystem productivity or net biome productivity. Because net ecosystem productivity is nothing but it is the exchange of carbon take place between the biosphere and the atmosphere. Carbon stock, that is a one part of a pool, vegetation carbon pool, soil carbon pool, atmospheric carbon pool or ocean carbon. So that refers to the amount of carbon that is stored in the reservoir. Reservoir may be atmosphere, soil, vegetation or ocean, and commonly include carbon stored in biomass, soil, ocean, forest product and other physical entities. Then we have carbon fluxes. That is nothing but it is a flow exchanges of the carbon between different entities or vertical fluxes. The flow of carbon is vertical fluxes and usually measured as a mass or volume of CO2 per unit area per unit time. That is a fluxes. Fluxes we measure with the gradient. So whenever there is a gradient in the CO2 between two height, we can measure the fluxes. Another important term is a gross primary productivity. This is well known to most of the students because gross primary productivity is nothing but it is a gross photosynthesis. And it is represented as amount of carbon fixed via photosynthesis in plant canopies. That means how much removal of carbon from the atmosphere and its conversion into a dry matter or biomass during photosynthesis is called GPP or gross primary productivity. So it also depicts carbon assimilation in the plant canopies, including respiration, photorespiration. Terrestrial GPP has been estimated to be a 120. Okay, if you see, as I already told, on an average it is around 121 to 122 pentagram carbon by 2010. It was on global scale. Then another term is a net primary productivity, because whatever gross amount of carbon being fixed by the photosynthesis, all is not being utilized for biomass. There is a difference in the between the carbon assimilated through photosynthesis and carbon release or consumption by the respiration through leaves, stem and roots. As I said earlier, there is a uptake of carbon via photosynthesis and there is a release of carbon via respiration by vegetation. So if we do difference between the GPP and the autotrophic respiration. Autotrophic means autotrophs, plant, stem, bole, leaf, stem, bole, all respire. That is called plant respiration. So if we subtract that autotrophic respiration from NPP, we can GPP, we can get net primary productivity. So it is almost half of the GPP is an NPP and half of the GPP is a respiration, autotrophic respiration. Third term is a net ecosystem productivity, or you can say net ecosystem exchange of carbon. It is nothing but amount of carbon that is being exchanged between the biosphere and the atmosphere. What we can term it as a carbon flux. This is vertical flux of the carbon exchange. So it is a merely difference between the net primary productivity and heterotrophic respiration. That means once you subtract amount of carbon released by the microbial respiration, soil respiration and root respiration, then you can get net ecosystem productivity. So which determines the amount of carbon lost or gained by the ecosystem without disturbance. So net ecosystem productivity doesn't include any disturbance like forest fire, land use change or harvest. So net ecosystem productivity is equivalent to amount of carbon exchange between biosphere and atmosphere. It is around estimated globally to be around 10 gigaton carbon, or you can say 10 pentagram carbon per year. Gigaton carbon is equal to pentagram carbon. Okay, so this is 10 gigaton carbon per year. You see with the schematic diagram, GPP, that is from sun energy, gross photosynthesis, autotrophic respiration, that is RA, it is released from the plant. Then NPP, this GPP minus RA. Then comes net ecosystem productivity. Once you subtract respiration release of the carbon by heterotrophs, you will get net ecosystem productivity. Even further, if you account for the disturbance, like amount of carbon which is being released by the forest fire, land use change or harvest, crop harvest, like seed grain. Because in case of agriculture ecosystem, whatever carbon is being uptake or stored in the vegetation, most of these crops, their seeds or biomass, it is being fed to the either cattle or it is being consumed by the human being. So after it has got a very short half-life. In short time of process, it is being released to the atmosphere through respiration, either by animals or by human being. So it is not stored in the vegetation. It has very short half-life. That is why that it is considered as a harvest. This crop harvest, it is consumed and released to the atmosphere, so it is going as a release of carbon. But there are well-managed ecosystem which has got uptake, very high uptake of carbon compared to the crop harvest. Total uptake is very high, and finally it may be a sink of the carbon also. So decomposition of substrate matter, organic matter through microbes is a soil respiration, which is releasing as a heterotrophic respiration to the atmosphere. So this already I talk in detail. I talk about this in next lecture. So here let us understand the exchange for Earth observation for exchange of carbon and its equivalent. So there are different kind of in situ measurement and observation you can devise from the space. So particular in situ measurement, we have already globally there is a growing network of the observation site, particularly flux tower site by ADCORANS site, which have ability to measure energy, water vapor and carbon dioxide exchange between the vegetation system and the atmosphere. So this ADCORANS tower, which are ranging from the small 3 meter tower for the cropland to the almost 100 meter tower for the some forest ecosystem. India particularly, we are now gaining momentum with respect to the strengthening of the this ADCORANS of flux tower network to study carbon cycle and the climate change. As of now, okay, it is almost 25 plus towers are being set up across different ecosystem within India by various agencies, including pioneer by ISRO, then Indian Institute of Tropical Meteorology, MOAS, then ICR. All are engaged in the understanding sink and source nature of the different ecosystem to quantify terrestrial carbon contribution to revised target of reducing carbon emission. Now here you see fluxes, you can monitor CO2, H2 methane with the tower. Then meteorology, also you can monitor slow response sensor, meteorology, temperature, power and humidity. The soil moisture sensors are also there, soil moisture, temperature, soil respiration system, all are located within the tower observation site. You can monitor all those soil related observations, which are very plant properties like leaf area index, the diameter at which side, fraction of absorbed photosynthetic active radiation, all are the in situ measurement which are required for the fluxes. On the other side, space observation over the period of last 20 years, if you see nowadays, historical archive of the observation available from the IIRS, Modi's, Spot VGT, even Indian ISRO satellite like OCM or IIRS sweeps, many observations on a period weekly or fortnightly basis are available to quantify vegetation status, like biophysical variable NDVI. NDVI data set is available from different satellites, IIRS, Modi's, advanced sweeps, or other satellites also, with historical archive also. So we can quantify this for vegetation strength or vegetation vigor. Nowadays, new sensor development is there with respect to the better quantification of the photosynthesis, that is the sun-induced fluorescence. Now, earlier NDVI is a proxy for the vegetation vigor and biomass, but SIF, it is much more closely related, or we can say better proxy for the photosynthesis, which is being developed. And nowadays, last 6-7 years, satellite sensor like GOM on METOP and also OCO2, and then there is a GOSAT, various greenhouse gas sensor itself carrying the SIF signal, measuring the SIF signal, and which will be very much good for the inferring photosynthesis. Then LST, land surface temperature, evapotranspiration, because evapotranspiration is closely linked to the photosynthesis. So based on evapotranspiration, we can also quantify the amount of carbon being fixed, because both are reciprocal process. Then gas itself, columnar retrieval of the concentration of various gases like carbon monoxide, particularly XCO2 and XCO2. The inversion of CO2 is possible with the greenhouse gas satellite like GOSAT and this OCO2, and then SIMACHI, all the different giving carbon monoxide also. So with that carbon monoxide, information of carbon monoxide and the oxygen band present in the this greenhouse gas satellite, which is very much useful for identifying the sun-induced fluorescence. Then meteorology, insolation and power. Now there are many geostationary satellite data. Geostationary satellite sensors are being evolved or developed. Like India, we had Kalpana VHR or VHR, INSAT. These provides hourly images of the satellite. So from MOSTEC at the Space Application Center, we can get daily solar radiation database over whole India. Similarly, Meteosat second generation satellite has got Saviri satellite, which also has got capability to provide daily and hourly solar radiation database. So these all solar radiation data, they are driving forces for the photosynthesis. So they are very much useful. Then plant properties. Nowadays, a leaf area index, height can be possibly very accurately estimated from the LIDAR and other kind of sensor. Plant functional type, you can map. LAI also. Leaf area index. Now Modi's LAI product available for last 20 years. So here key observation element of terrestrial carbon cycle, particularly with respect to the carbon pool, land use, land atmosphere carbon pool, and land atmosphere fluxes and disturbance, particularly forest fire, land use, and crop harvest. So here particularly if you see land atmosphere fluxes with ground-based observation like flux tower network, across globally there is American flux, OZ flux, Australian OZ flux, Africa flux, Euro flux. There are network of Asia flux, where okay we will find network of flux tower observation. Presently more than 600 flux tower sites are being operated under the global flux network program, FluxNet, and these all providing the hourly to daily and annual database on the ecosystem fluxes, particularly photosynthesis, net ecosystem productivity, respiration, and carbon evapotranspiration and later sensible heat. Likewise, okay, ecosystem dynamics also we can monitor. Carbon pool, mainly litter and soil carbon, and vegetation biomass carbon. There are okay many satellites like even our Landsat, Sentinel, and also this LIDAR. Now LIDAR it has got ability to provide correctly the height, stand height. So it has become vital for correctly estimating the biomass carbon of the forested landscape. So these all vertical structure, canopy cover, biomass, phenology, canopy chemistry, all can be possible to derive for the information for vegetation carbon pool, and also some information like soil moisture, soil organic carbon, all with the site and integrating with the satellite data, we can infer information on soil carbon also. Land use, land cover, crop area, urban area, different kind of cover dynamics. We can monitor with the land use, land cover change databases. So overall, remote sensing or earth observation data available as on today has capability to provide information for different key aspect of the carbon cycle like carbon pools, land atmosphere fluxes, as well as disturbance. So India, okay, this is just one. I am showing that there are 4 sites what IIRS has set up for measuring and monitoring carbon exchanges between the different agro-ecosystem and natural forest and the atmosphere. So we have this northern western Himalaya, we are operating all those sites and constantly monitoring carbon exchange across different landscape, Himalayan landscape of, as well as Indo-Gangetic plain. So different output like carbon fluxes, net ecosystem exchange, and all is being monitored. So this is one also flux tower. What is status I am showing you that flux tower instrumentation network is established. Similarly, on similar fashion, we have our at NRSC in MP and Sundarban mangrove site, MP Betul forest site, and also the Indian Institute of Tropical Meteorology, they have established somewhere 5 to 6 flux tower sites across different forest and grassland ecosystem. So all these different agencies are working to establish site and measuring this carbon exchange to better quantify the carbon cycle and carbon budget. So any observation site, that flux tower site, which has required fast response sensor and the slow response sensor. Fast response sensor mainly the grass analyzer and some meteorological sensor, along with the sophisticated instrument for measuring biophysical property like septometer, soil moisture meter, or some leaf area index meter, or chlorophyll content meter. All is required along because only tower data without having correct information about biophysical properties on the ground will not much value. So we need to have monitor both biophysical property as well as the carbon exchange at the site scale, and this site scale will be further information will be upscale or more upscale to the region landscape or regional scale with the certain remote sensing and model. So here you see these are different flux net site. So in India, that one Saharanpur where we are monitoring. So sugarcane is one of the GPP. If you see, very high amount of GPP is there in case of sugarcane wheat ecosystem in Saharanpur, and it is one of the most high biomass carbon site, and appears to be a sink of the carbon. Similarly, forested site also Barkot and this Kaziranga and also Darjeeling by IITM as well as the NRSC, our ISRO sites as well as IITM. All you see, India, there is a very high amount of carbon is being sequestered by the different vegetation system across India, and this network has been growing day by. Once we will have enough number of towers, representative tower site, it will help us to better constrain ecosystem model for carbon cycle studies. So that is what I am telling. The surface-based observation site, they are good. They provide high quality measurement for greenhouse gas concentration, but they are sparse and not distributed uniformly. That is why there we require satellite information. Satellite can provide accurate, abundant information of global measurement at regular period of time and interval by its synoptic viewing ability, multispectral nature, as well as frequent revisit capabilities. So this unique characteristic of Earth observation satellite helps to derive different kind of properties which are related to the carbon, or we can say carbon related properties. So different agency, whether it is a NASA or European Space Agency or Indian Space Research Organization, all are involving or developing satellites which has got tremendous and immense potential to provide information on the carbon related properties through remote sensing platform. Observation from space mainly useful in evaluating and reducing uncertainty in estimation of these carbon pools, fluxes, monitoring, and also variation in these pools and fluxes over time. Because these observation sites are very limited in most of the developing countries. But if you want to correctly quantify the carbon budget, we need to integrate this all observation along with the satellite observation to accurately quantify the carbon budget and generate national scale partial database of the carbon balance, so we can better pinpoint or identify the sink and source nature of different our ecosystem and give correct input to the national program on climate change. So here how remote sensing is helping, particularly land core mapping. So I am not going into detail. Already we have discussed all those things in last slide. Key observation for the terrestrial carbon cycle. So phenology, surface meteorology, leaf area index, environmental constant, and photosynthetic efficiency. All there. These are the area which are very much useful for the biophysical property, which are very much useful for the carbon cycle assessment. So this only I am giving you an overview, because next lecture where in upscaling and modeling of carbon fluxes we'll see in detail. But these whatever observation work we discussed with the flux tower site across India and also model. So we have to integrate those observation, whether it is a GPP, NPP, and net ecosystem exchange, or also some parameter quantified for the specific terrestrial ecosystem, like quantified quantum yield, light efficiency of individual biomes. We can quantify it based on the tower data set. those which are in those parameters are essential parameter for different kind of ecosystem model, whether it is a process based or the efficiency based. So here that light efficiency parameter can be determined from the this flux tower network for different ecosystem, and PAR you can get from the meteorological satellite like geostationary satellite. FFR you can get from the remote sensing satellite or for those satellite. We can finally model net primary productivity. So this is how this flux net observation can be integrated with the ecosystem model for deriving NPP and finally the net amount of carbon that is exchanged between the terrestrial biosphere and atmosphere. So variety of models are there. We'll discuss in detail all this thing in the third lecture, that is upscaling and modeling of carbon fluxes. So I am not going into detail, but just I have put one slide for you to see, have a look, that these are the different kind of model which are highly amenable to the satellite observation. So we can use this along with the satellite observation for deriving different component of the carbon cycle. So you see some models like some quantification we have done for over India. So there are different kind of models, CASA, CFIX, and Modi's NPP. Different algorithms are there. So here you see total NPP of India. It is ranging from 1.45 to 1.34 to 1.6 pentagram carbon. Now Modi's NPP, which is underestimating 1.34 pentagram carbon, CFIX it is 1.45 pentagram carbon, and CASA model, which what we have implemented with the spot vegetation data, 1.6 pentagram carbon. So this is all. If you implement this kind of model for region specific, you can improve its accuracy of computing carbon absorption or NPP. So different kind of models are being practiced. You see this NPP and NEP over India, people have studied. Like CASA, we have studied with the atmospheric growth rate is 0.005%. 1.5 pentagram carbon is there for whole India. Then NEP, net ecosystem exchange of carbon between biosphere and atmosphere in India is 9.5 teragram carbon with growth 1.8 teragram carbon per rate. Similar kind of values also quantified by a dynamic land ecosystem model, that is 1.2 to 1.7 pentagram carbon. When we talk about ecosystem exchange, that is a net ecosystem exchange or net ecosystem net amount of carbon which is stored and added to the soil. That is actually the amount of carbon which is stored and added to the soil is a net biomass productivity. So net biomass productivity, even it is increasing in India from 1980 to 2000. You see, most of the model which is being done, implemented in India, showing increasing the amount of net amount of carbon being stored in India beyond 1980s. So terrestrial carbon sink is being increasing over years in India, and it is very much quantified with the different kind of models. Globally, if you see even globally also, carbon sink, if you see, that is a total carbon sink, as I told earlier, gross primary productivity is almost 120 pentagram carbon. If net ecosystem productivity means net ecosystem exchange is around 17 pentagram carbon. As of now, this is a current database. So various sources of data like even data flux net network, satellite estimate, forest inventories, process-based model, all can be used to synthesize carbon budget like global carbon budget, what I have shown. It is all done through different for fire emission, net biome production, land use change, crop harvest, dissolved organic carbon, volatile organic carbon, all different compounds. They are source or sink, all are synthesized to derive the carbon budget. So if you see the northern area and southern area of the global, particularly photosynthesis, the terrestrial carbon sink has been increasing. gross photosynthesis rate has been increasing over the period of time. Particularly, northern growth rate of atmospheric CO2 with northern dominate, means tropical variability any dominate interannual growth rate of atmospheric CO2. GPP, these are GPP or gross photosynthesis. In generally, they do not have strong role for the respiration, particularly for fire and respiration. Why they are not directly explaining net amount of carbon exchange between the atmosphere and biosphere in tropical region? Because in tropical region like India, there is a large degree of forest land. Even you see last 2019, large number of forest fire events were there, and also there is a respiration process. So photosynthesis does not directly related with the net ecosystem exchange. So this, okay, I am not going into this two slide. Okay, I'll see in the next last, okay, future thrust area. That already we have discussed what are the different views, future sensor, requirement solution, gap limitation, all available. We'll discuss in the third lecture about, okay, what are the future sensor requirement for modeling with the Earth observation, what are the gap and limitation with respect to the carbon budgeting and modeling, and present sensor, existing state of sensor and its capability for the carbon budgeting. But apart from this, okay, forest fire, how forest fire impacting the carbon sequestration, it is also being possible to quantify with the large amount of database generated over India on forest fire with the Modi's data. So forest fire count, okay, if you see that biomass carbon which is lost due to forest fire is 0.7 to 0.8 megacarbon into megacarbon. So here particularly you see that in 2009 this much carbon is lost. So partially explicit we get information by taking into account the GPP, active forest fire product, land use land curve classification. This is one study being conducted by one Sanigrahi over India by integrating these carbon fluxes like GPP and also forest fire account count from the Modi's and also land use land cover change emission and the things. So this finally we can identify how much forest fire, because of forest fire, how much emission biomass carbon is being burned and how much forest fire has affected the biomass losing of or biomass from the Indian forest sector, now forest landscape. Now let us have a look at the different kind of challenges what we can face with respect to the terrestrial carbon cycle, particularly with respect to the biomass carbon pool assessment. We need to have a sensor like application of LIDAR and cartosat 3D data, which can view accurate estimation of canopy height and 3D model. Like even now, these days, digital camera is available. With the use of digital camera, kind of camera, you can construct the 3D model of the canopy structure, canopy, whole canopy, tree canopy, individual tree canopy, and you can compute the biomass. So this is a challenge. Okay, now newer technology that can be used, LIDAR, 3D camera, and this also cartosat 3D, different kind of data are available which can be integrated to derive the canopy structure parameter as well as canopy biomass. Then improvement in the RS-based scaling or modeling of the NPP and net ecosystem exchange between vegetation and biosphere. Because of improvement in the strengthening of flux tower observation, we can more and more use this observation to constrain this biospheric model like CASA or some process-based model like the dynamic vegetation carbon cycle model. All can be constrained with the available network of flux tower observation to improve accuracy of carbon budgeting. Then we need to also strengthen flux tower and also assimilation of this flux tower observation directly into ecosystem model. That is another area of developing assimilation technology. strategy. Fourth, application of data mining. Large amount of data is available on soil, organic matter carbon, vegetation carbon, different plots, thousands and thousands plots are being laid out for deriving vegetation carbon, biomass, and also soil carbon. All these can be brought to the partial to derive partially explicit information on soil carbon pool, vegetation carbon pool, if you use certain kind of data mining technique like random forest or a artificial neural network or certain deep learning techniques. Modeling soil carbon and respiration, because respiration is one of the critical process because that consume almost 2/3 of the carbon which is being emitted from the land is only through soil respiration. Unless and until we do not quantify correctly the soil respiration, it is very difficult to close the carbon balance effectively. Carbon balance in terms of what I mean to say, net ecosystem productivity. So we need to have a observational good amount of observation on respiration as well as some newer models like some models are available, Rothmist, Century, some models of respiration is available. We have to go further with the different land use, land cover and climate regime. We have to study the respiration, soil respiration across different landscape and integrate those database into a different kind of ecosystem model. Apart from this, we need to also very good amount of atmospheric CO2 measurement. Because finally, inversion of CO2 model, inversion of transport model or atmospheric transport model, which are very top-down approach. There is the bottom-up approach and top-down approach. Based on top-down approach, to facilitate top-down approach, we need to have a better measurement of the atmospheric CO2, carbon dioxide also with the more balloon-based sensor, airborne survey as well as Fourier transform infrared radiometer. Now, what are the issues? There are certain issues like because we have enough in globally, if you see American flux and Europe flux and Australia, they have enough number of sites. Even our South Asia also, Malaysia and then Korea and China, they have also large number of flux observation sites are there. But in particular in Asia flux, are we operating these all sites as a just site for certain measurement, or we are developing it into a super site? Like Australia, they are generating carbon balance, carbon budget for globe also. They have many agencies being working. Now we have to also see that they are operating different flux tower site as a super site. So shall we develop these all flux observation site as a super site? So it can be useful for validating any kind of ecosystem model, or it can be used to integrate with the satellite observation in the present context as well as in future new sensors available. So observation is required to have without gaps and instrumentation weakness with the same protocol or for the instrumentation, data procedure and exercise. So, but mainly, very frankly speaking, this all some flux tower site doesn't have whole year observation because of some instrumentation error. All is there because we are not operating it is a super site. Later we can have few observation site, but it should be a super site without any gaps in the data set, so we can better understand carbon cycle and finally give input to the long-term monitoring of the carbon data balance and finally input to the national climate change program. Then we have to develop also new sensor for continuous measurement of spectral reflectors, some light transmission phenology. Like different kind of sensors are there. Digital camera, spectrometer, LED, or regional regular basis. Like nowadays, many spectral sensors, like directly NDVI normalized difference vegetation index, photochemical reflectance index, which are very good proxy for the vegetation, photosynthesis, all those things can be monitored on the tower site itself with a certain kind of spectrosensor. Digital camera or 3D camera, they are useful, or smartphone, all are have great capability to collect ground truth, also collect field measurement with the latitude and longitude, and also get the information on the stand height and other parameters. Third is okay, some how good, okay, we have been doing, okay, people are doing across globe. There are different kind of models are being used, and also people are collecting this flux tower database and at a different scale, whether it is a regional scale or global scale, whether we should have this all database daily scale or annual scale. There is time scale is very much important, and partial scale is very much important to integrate data. Because suppose we are working out the regional carbon budget, like for Indian our national carbon budget, then we should have a kind of satellite observation that meet the scale of 1:50,000 scale, or 1:5,000 scale, or 1:50,000 scale. What kind of map we are going to produce, that is important. Also time, whether monthly or annual carbon budget. So that is all important to study with respect to the availability of satellite observation as well as the flux in situ measurement. Because unless we do not enter in situ measurement, even though we can use fine resolution satellite observation and generate some carbon balance, which has got little authenticity. So we need to have both development with respect to both increasing in number of observation site along with the satellite satellite observation, both spatial as well as temporal resolution, to meet the requirement of national carbon budgeting. Then models. What kind of models should we use? This is also what are kind of models are better amenable to the Earth observation, like both in situ measurement as well as satellite. In general, efficiency-based model like are amenable to this satellite observation, but they are having also certain issue. They cannot be implemented on a sub-daily scale. Also, they are not okay. They require data. Observation data is voluminous. So model tend to oversimplify and may miss some key processes and linkages, like efficiency-based model. They are very simple. So they certain kind of process like stomatal regulation, or certain photosynthetic process, or certain enzymatic activities, or certain linkage with the evapotranspiration of this process, ecosystem photosynthetic process with the evapotranspiration. This kind of linkage which is missing in the efficiency-based model. So we need to address these through assimilation of satellite observation directly into a process-based model, which are better descriptive of the key carbon cyclic process. Then what I already said, whether efficiency-based model or process-based model, what kind of model we shall implement for our country. Third is a consistency and compatibility of model. We have to have some model, like we have been using CASA model, it is compatible with the satellite observation, and also we have validated. But whether it is compatible or it is inconsistent with the flux tower measurement, that we need to test it. Now there is a other need to test compatibility of all ecosystem model being practiced for our region to accurately estimate carbon budget with the ground observation site. So this is all about what are the different challenging we have and status, and also some basic information about Indian carbon cycle, also Indian carbon cycle related projects, observation sites, what knowledge and experience we have, and how we are going to go ahead. What are the challenges we are facing? What are the issues? we encounter all while modeling carbon cycle. I shared with you in more detail. We will discuss in the next 4 lecture based on mainly land atmospheric fluxes, modeling of fluxes, vegetation carbon pool, and soil carbon pool. Thank you very much.